app that'll be on those computers?
Yeah, well, we're gonna download the virtual machine. So I just want to make sure I have the assignment available for you first too. Let's do share because okay, so today we're going to talk about network services. This is a very, really important area for IT and cybersecurity only because you will be working directly looking at the type of services that the network is running, and then potentially how to secure the services if you're in cybersecurity. And then if you're in networking, you have to make sure that these services are available. So some of this might be reviewed from earlier sessions and also some classes, but we'll kind of dive a little deeper into talking about how these services are relevant to your daily operation. You know that IT is really the operation for business. Without the systems, you will not have sales terminal, you will not have e-commerce, you will not have email. That's really important for a lot of the department. So to start, it talks about DNS, and you are going to install DNS, and I chose a newer version of operating system, and I recreated the virtual machine for the class because the other one was kind of slower and limited. So your domain name server is required in your to be able to support your web server. This is how you would have google.com, youtube.com. So when you are hosting a website, it is tied to a domain name, and that domain name is being used in a server environment. This allows us to tie the public IP to a URL. Now, your host provider like AWS or GoDaddy or one of those companies, they have these servers running, and you would be able to implement it. Now, internally for an enterprise, you would have a DNS for your domain. So for example, if my company is abc.com, when you're looking at the hierarchical, right, the root is where you would see where it's the dot, okay? And then the top tier level domain is the .com, .gov, .edu, .net. And so in some cases, if you host a domain that uses a lower tier, right, in the actual hierarchical structure, you might see like .io, .it, and so on, .me. So in this example, what you see is you would see that if we have Microsoft.com, right, that would require a DNS server. And that DNS server would have the records, which are files that are associating the IP, the URL to the IP address. The computer, it only cares about addresses and numbers, right? We designed the computer to communicate with other systems via numbers. But as human, we have to interact with the computer. So therefore, we have to create a system that associate address to a name. So what you see here is that you might have internal or external DNS. So for a company like Google or Microsoft, they would have internal DNS that would manage, that we use to be able to create a domain. And through that domain, we can create zone for the systems. Now, when you're looking at the design in the network, you typically see for those enterprises, they would have external zones. So external zones are public facing. That means that you would have web servers that are tied to the external DNS. And then you would have relevant servers, right? Like message server or email server, and databases that would be tied to public users. So what you see is that we would sometimes create different domain names to separate the internal and the external zone so that way we can control the environment a little better. Now, the third-party hosted zone, those are like the AWS, those exist at the data center. And basically, you're leasing their servers. Or if you're using Azure, or GoDaddy or one of those web hosting website, then basically you're using their DNS and that exists on their data center on the racks, and you're renting that server or leasing that server for the service, right? And then you can tie your web server to the DNS so that way you would have an actual website. And this is what you see. I think we're at like close to 10 billion now across the internet around the world. So now, when you're looking at the child domains, you often see something like, I might have company like abc.com, and then I might have like a subdivision of it. So I might have like, let's say branch1.abc.com. And so when it's before the actual domain name, it becomes a subsidiary of the domain. And you do see this when company acquire other companies. They might keep the domains in separate, where they keep the original name, or when they absorb the company, they actually create a subdomain of the original domain. So in a structure like this, you would have a primary domain controller that controls all the other domains. And then you have what they call a secondary domain controller that would substitute the primary in the case something happens. And then anything below that, you would have the child domains in the subsidiary. So that means that you can change and the configuration at the top level, and it would trickle down to the subsidiary accordingly. And we would synchronize that throughout. So let's go through and answer some question. Is that big enough? Okay. So how can you set up an internal and external DNS zone? And when you go through the lab today, you would see that you would create these zones, and each of the zone would have its own records. These are just files that it would use for reference for the IP address to a domain name, right? We go around and we say, oh, my domain is Microsoft.com, right? We don't go around and say my domain is 14.12.8.11, right? Because it is just harder for the human to actually remember all of those numbers. So we create the system that would be able to correlate, right, the structure of our domain to IP address. So when you create separate zone like this, they have separate records, and in cybersecurity, we would do our best to protect those records because, as you know, DNS farming, right, or poisoning is a common technique. I'll just zoom in a little bit. A common technique or attack that's used for corrupting a DNS, right? So if you have a server that have the records that's essential to the domain structure, if somebody wants to redirect the users and the system to another server, they would modify these records. So therefore, it's important that we think about how we can protect these records so that way everything, all the objects and the subject that belongs to our domain is also secure, right? So when you create these zones, the records will be created accordingly based on your domain names for each of the zone. So when you install DNS, you would see that. Now, the difference between the forward and the reverse lookup zone is that the forward lookup zone, it uses the fully qualified domain name, hence your URL, right? Like your like Microsoft.com to the IP address, okay? So automatically when you install the DNS, you usually would configure the forward lookup zone. And this is what you see today when you do the lab. Now, the reverse lookup zone is a way that we can correlate the IP to the fully qualified domain name. So when I say a fully qualified domain name, it's Microsoft.com, Google.com, right? NBC.edu. So you would be able to create your domain name and you would set up the IP address of your server so that way it creates the record for that. Now, if you're using IPv4, it would create the A record. If you're using IPv6, it would create the quadruple A record. Okay? So typically, you often see that administrators or the people who configure the DNS, they don't necessarily set up a reverse lookup zone right off the bat. Often that you only require to do a forward lookup zone, so that way if we are looking for a domain, it's able to say that this domain name has this IP address. And publicly, you have a list of DNS, right, that would have a list of IP addresses. Some companies like Amazon, Microsoft, Google, right, they have lots of public IP addresses, right? And with that, they're able to provide those IP addresses or use those IP addresses with domains. So you see hosting company would own a range of IP addresses, and these zones would have the records that would be the reference for the system. So when you create your zone, the wizard is going to walk you through. So typically when you start building a DNS, after you install the service, you would create a primary zone. And this is a writable copy for the DNS database, okay? Now, the secondary DNS zone is a read-only copy. That means that you can view it, but you cannot modify it, okay? It's gonna receive the information from the primary zone. So the secondary DNS zone doesn't really exist unless you already created a primary DNS zone. So when you configure the DNS, right, we would start with a forward lookup zone. Inside it, you can create your DNS zone. And we'll talk about why these zones are important. So with that, you would see some records being created. Okay, and you're gonna see that today when you go through and you set up. So here are the records, and a lot of these don't make your questions because I only have like so many questions, but I want you to know these so that way in the future, if you are taking certification or if you are setting up your server, you would know exactly what they are. So when you resolve fully qualified domain name to an IP address, I already talked to you about that. It creates what's called a host record or an A record. So when you click on your DNS after you configure it, on the right pane in the DNS management console, you would see the records associated with the zone that you created. Now, if you're using IPv6, as I mentioned, you would have quadruple A host record. Now, alias is a record that uses a name, and that name is created to associate with an actual domain name. Okay, think of it like a nickname. Okay, we can use a nickname, which is an alias for our domain, so that way it might be shorter, it might be easier, it might be. So when you create that, when you set up the zone, you can have an option to create an alias record, and that is it has a name and it points to the host record. So it's a way that we can give it a nickname, and that nickname is going to point to the fully qualified domain name, which resolves to an IP address. Today, you're also going to see name server, and this is for DNS that is taking the authoritative role. So this is a way that we can find domain IP address. So without the NS record, we cannot find a way to access the actual IP address. So it uses domain name to an IP, and a way to find that IP address is the NS. So you automatically gonna see that we're gonna have an NS record, okay? And if you also have authoritative role in your DNS, you also gonna see the SOA. this allows you to store the settings of your DNS zone, and it's going to, and whenever that you modify or you change your zone, it's going to update, increment the number so that way that you know that you have different version or different changes that you made in your primary DNS server. And this is a way that we can track on how we modify your DNS. So if you have a different increment number and the secondary DNS knows it, it's going to then require a synchronization or an update, right? So it's a way that it knows one DNS is modified and the subsidiary DNS, like the child domain, needs to be able to obtain that information. So it checks this record for updated number so that way it knows if there's changes to the system. And then you have the SRV record. So make sure you know these records for our quiz and final exam. They will come up. Okay. So with that, let's go to the next few questions. So for 4, it asks you to identify the type of records based on the given functionalities. So for A, to specify the DNS server that is an authoritative domain, and you can set it, right? You can authorize it, you can set it. I think when you are doing that in Server 2022, they kind of modify on how that is used now. We would be able to right click and then be able to set that up. But now I think that when you set that up with the wizard, it automatically kicks that in. So it is a way that we can find the domain IP address. So it would work with your reverse lookup, right? Where you would need to find your domain through an IP address. So when you create that, you would also see the NS. And then your CNAME is, like I said, is a nickname or an alias record. And that is, it creates a pointer that points to the DNS. So we can use a record to point to the host record. So they are basically just files. And then we also do the same thing for the reverse lookup. So you would have a PTR, which is known as a pointer record. And this is going to be created when you create a reverse lookup zone. So if you don't have a reverse lookup zone, PTR doesn't exist. Okay, this record will not be created. And some network administrator, they don't set up the reverse lookup zone, right? You can. And then for D, store settings for the DNS. And this allows us to see the changes from the primary DNS. And so that way all the subsidiary, like the second DNS server would be able to check this so that way it can do the update. So that's SOA. So the protocols that's used to allow the system to contact the DNS for records, especially for the SOA, is what's called a dynamic DNS. Now, you don't have to configure this right off the bat. Normally, I don't recommend that when you go through the installation. It doesn't let you anyway. So once you have your services running, then you can go in and you can modify your configuration. So it allows the DNS server to contact one another for updates. So if you have multiple DNS, dynamic DNS update is ideal, right? That means that we can modify the configuration at the top level, and anything below that in our enterprise, in our infrastructure, will have the update. Now, typically for Microsoft, it's slightly under an hour when it does the update. You can also run Active Directory so that way you can add users to your domain and groups and system, and then you can replicate it. So that way you don't have to go to each individual server to configure the DNS and its Active Directory. Okay. So when we elevate it to top of the forest, it automatically becomes the most high level. And then you can also add to the actual hierarchical structure for the later DNS. Okay, so dynamic DNS, you can find this on page 2. And there are 2 approaches to this. So long ago, we can run the updates in a non-secure way. That means that the system communicate and there's no protection in that communication channel and the data that it has. But later on, we found out that that becomes a risk in a network. So that means that your records can be jeopardized. Somebody can intervene and modify your records. That means that they can redirect, right, to their own system, their own server, their own network. And this is what you see with a lot of phishing type of attack, is that they typically get your domain user to be able to access, right, to believe that they are still in your infrastructure using, DNS records and then modifying it. So you see that in farming attack quite a bit. So we want to have secure updates. That means that we can control the access for configuration. So any question regarding DNS? Okay, so make sure you know what DNS is for Network Plus certification and our class and its associate records and zones. I know that you configured DHCP a while back, right? Because when we talked about IP addresses, you had gone through and created a scope. So I want to do a review for this because you are going to see it again today. So typically you are going to have, let me take 5 down to the next page maybe. Typically you are going to have multiple services running on the same server. A lot of companies are using cloud-based infrastructure. That means that I'm renting a rack at Amazon data center and I am spinning up my servers as instances. They are running virtual machines. So you're using their hardware and you would install, right, your services just like what you see on your virtual machine today. So that just means that you are controlling it remotely instead of physically at your own facility. So you would see that a lot of the system would have DNS, DHCP, and Active Directory together. Will you have systems that are separate? Sure. You might have multiple physical servers that are running DHCP if you have a very large enterprise and many scopes to be able to release. If you have a single point failure, if you are running multiple services on the same instance, what will happen is that you will have down, right? You will have disruption in your operation. So when we create a DHCP scope, as you saw in the prior lab, you simply create a range of IP addresses that you want to lease out to your client system that are running Windows 10 or 11. So let's say that I'm working from home. My company is mostly remote. I'm logging into the domain and my authentication is, my security token is then be given because I authenticate through the firewall coming into the network using remote access server. Once I am in the network and authenticated, my security tokens is going to grant me access to my company's network, like application, resources, files. And with that, we typically give out the IP address for those systems, right? Even if they're connecting remotely. Now, in the internal company, as you boot your computer sitting in the lab today, right? You're using an IP address in the scope. So what you want is you want to be able to set up the subnet and the range in that subnet that would be adequate for that section of the network, that segment of the network. Why? So for example, if you are logging into the student side of the network, right? You are getting a different set of IP address compared to the staff and the faculty systems, because that way we can control the type of access that these systems, the resources that they use by using subnetting and also creating the IP addresses for it. you would be able to manage it on the switches and along with your server, so that way you can increase your scope or modify it. You can decrease your scope so that way you can scale accordingly. And also you would be able to control like who should have the IP address. And that's really important to think about from a security perspective, versus just administering your IPs. Now, when it goes through the process, so I want to flip back to the notes real quick so that way you can see. So when you turn the system on, it's going to send a broadcast message, which you see that it's all broadcast address, which are Fs. It's going to say, who's my server that's going to give me the IP address, right? It's going to send that to every system in the network. And the DHCP server is going to say, I am your server. So it's going to offer, and I will give you an IP address, okay? And then the client would then request the IP address. And once it releases the IP address, the acknowledgement is then sent. Say, I gave you an IP address. So this is the process, because this is TCP, the DHCP is under TCP. You have the acknowledgement and you have the request and acknowledgement. So when you're running Wireshark and you're monitoring this activity, you would see, right, the packets, the request that's coming through for your client. Okay. Now, if so we'll talk about how this can be. So you can manage the addresses in the pool, and I give you the actual steps. Okay. Now, we talked about time to live before. So the length of time that the client will have the IP address assigned. So when you create your scope, you can set it for 90 days, 60 days, 30 days. That's really depending on how you want to manage that as an administrator or an engineer. Some companies, they would have it for 30 days. So if you are limited with the IP address, you would reduce your leak, okay? If you have a very large scope and you don't have as many systems. So how do I know how big is my scope? Well, we learned subnetting already. We just want to make sure that we accommodate the number of mobile devices, laptops, desktop that are connecting to our network, and that's important, okay? So that's why subnet is usually tied to the scope of your DHCP. And it talks about reservation here. Okay, so in that scope, you can reserve a few IP. Maybe I want to use it for printers, copiers that I later added. We should plan that out and use static IP, but in the case that you don't have static IP to use, you can reserve some of the MAC or the IP address for the shared system in your network, and that's important to think about. Okay. So you can set that with the scope, and Microsoft creates a wizard for you to do that accordingly. So for 7, it asks you what type of address is used for the discover message. Like I said, the computer, the client system, which are your desktop, laptop, and even mobile devices, it would send a message to all systems saying, who's the server that's going to give me an IP address? And you see this with all broadcast address. They are all Fs. So if you see IP address is going to be .255, but you're going to see the Fs because this is going to be at the lower level. So once it gets that, right, the server is going to respond and say, I am your server, and that's how it's going to offer. So after the clients receive the IP address that's from the DHCP server, the DHCP server would then send an acknowledgement indicating that this is your IP address. This is the lease time that you have, right? And this is the router information. And we see this, right? So if you open command prompt, and if you just simply do ipconfig, if you just look at your configuration, the information that you have, right, for your IP address is actually what the DHCP system offers, right? So if you do ipconfig space/all, hold on a second, you see all of this. Okay. So I'm able to have the DNS information, my default gateway, right? And then the server information. So how does it know this? Well, it knows it from your acknowledgement message. Okay. That's how it's able to have that information, is because the offer message at the end gives the system that information, say that this is your IP, this is how long you're going to have it for, and this is the network information that you belong to. Okay, any question? So can they attack you using this process? Sure. Anything that has request and response, someone can capitalize on it. Denial of service attack with DHCP is common. If you're looking at a remote environment, you're gonna see. So what a lot of the administrators are doing is that they want to set up systems that are gonna be the middle systems that can forward or absorb the traffic. So typically before, we would have a bunch of client system requesting one server that's giving out the IP from the scope. But what you would see is that if they launch an attack, they're going to target that DHCP server. And if that DHCP server goes down, then none of your system will have an IP address when they are requesting. So what you can do is you can set up a system that is going to wait for the discover message. It's going to listen and look for the broadcast message from the client. And that system would then take that message and send it to your actual DHCP server. Why would we do this? We would do this, number one, to save the bandwidth for that segment of the network, because if you have massive number of system requesting at once, your DHCP server will slow down. You're going to have a bottleneck. And that creates latency. So if I set up, like, let's say 5 relays to my DHCP server, those 5 systems can wait for the messages. And if you have massive number of message requests, they will handle it and they will forward it accordingly. But in an attack concept, it also allows the helper to absorb the traffic. So at that point, what we can do is we can also implement firewall rules to be able to check these before they forward it to your actual server. Because if they launch a denial of service attack or distributed denial of service attack, that means that it just keep on requesting IP addresses, sending broadcasts, and also that is going to create your segment in your network. So we can also use a relay to absorb that traffic, right? And then if it's not a legitimate request, it's going to then drop it at the firewall. So you can use like network intrusion detection system. You can use the prevention system, however you want to do that in order to create some kind of barrier to protect your main server that provides the services to the rest of your enterprise. Okay. And that can also be a segment into another class. I think I saw some of you that already took ethical hacking, and I think we talked about that in CIS-40A. Any question regarding DHCP? No? Okay. I think you experienced this. I would encourage you to re-practice some of the installation and configuration. Now, it doesn't necessarily have to be a Windows server, right? You know that some of these services can be handled with your network appliances. As you can see here, you can use a Cisco router to route the traffic to the appropriate server. You can also use a multi-layer switch to do that. And configuration in those appliances is different than what you see in the Windows Server environment. But a lot of times when you set up your DHCP, you would see that with Microsoft Server. But yeah, there are other form of server like Linux servers that handles that. But typically 90% of the business use Microsoft servers for this. And then you can use Cisco IOS or through using the appliances like a router to be able to do that.
How long can a DDoS attack keep someone down?
So it's as long as your system RAM is limited. Yeah, so the more RAM you have, the longer it's gonna take in the attack. And I simulated this when I did the ethical hacking. So when we launched a denial of service attack against our own simulated server, if you increase the RAM to 8 gig or higher, it might not go down in a single denial of service attack. But if you have distributed, so it depends on how large is that distributed attack. So if they're using like, 10,000 systems versus 1,000 system, that can also be a different form too. So the number of attacks that's coming in, if it's not dropped by your border firewall and it's coming through, it basically your system use RAM to handle each request.
Yeah.
And when it fills up that buffer, basically
That's the attack right there.
yeah, it gets confused. Yeah, so it won't be able to handle anymore. That's all it is to so if you maximize on your resource that you can handle it a little bit better. So by that time, so we're buying time with that, right? The more RAM you have, so we should be able to see that, and then we would modify the configuration for our firewall rule to now stop it.
And the number of attacks can be, I guess, you can use bots for that.
Yeah. So the way that they typically use is, they would acquire zombies by getting people to click and then, using their system to launch the request.
Okay.
Yeah. So, and there are different tools that you would use with that. So there are a lot of exploitation kits that are for different form of denial of service. So I think we touched on NAT before, network address translation. You see this today, and whenever you configure network configuration in your server, right? It's a way that we can take our private IP address or many, right, to be able to use one IP address, so we can share a public IP address with multiple systems. In most network, you probably would have maybe a few routers. Each of those routers would use a public IP. And then even for thousands of systems within. So NAT allows you to do network address translation. And it is common in wireless or home or enterprise environment. Okay. So there are multiple types of network address translation. One of the type is then if you're using multiple public IP addresses that's mapped to only one private, or I'm sorry, if you map one private to one public IP address, then you would have a static NAT, 1-to-1. Okay. For dynamic NAT is what you see at home. You only have one public IP address for your home router, but you might have 15 systems inside your home network, and they are all using that one public IP address, right? So when do I see static NAT? I see static NAT with mobile systems or IoT systems, right? If you buy a tablet or a smartphone and that SIM card that's tied to your public IP for your service provider, that's 1-to-1. But you can also set up NAT server to be able to manage network address translation. So if you're using a public IP address and you're using many devices in your network, this is what you see at home, overloading your NAT. So it's keep reusing that same public IP address, and all your system goes through your wireless router to be able to communicate to the internet. So you are loading network address translation. And your host machine and your virtual machine, right, it uses NAT, because my virtual machine, I need to use the private IP address for it with the host machine so that way I can get internet. So it does the network address translation to the host machine. And then the host machine would have network address translation to the rest of the network. So that's how you're able to get internet access within your virtual machine. Okay, so you can It's a way that we can keep our private IP private. Okay, and then it talks about NAT, static NAT and NAT overloading on page 5. And we often see port forwarding. We would use network appliances like your switch, your router, and be able to forward the packet. So my analogy for this, right, for number 12, it's asked you which of the following options imply the configuration of network appliances forwarding the packets to the system on the DMZ or the internal network. It's port forwarding, and you might configure this for game on your home router, perhaps. So analogy is that you might have 2 doors to enter a building, right? The main door and the back door, okay? The way that we set up port forwarding is to, instead of having it directly go to the front door, we are going to send the traffic to the back door, and from the back door, it's going to send the traffic to the front door. So we basically use 2 communication port. So it's going to go to the forwarded port, and the forwarded port is then going to tie to your main system's communication port. Now, you should monitor your port forwarding system because sometimes that can be also a flaw. But we would be able to do this so that way we can have appropriate services. Sometimes you can use an uncommon port, like I can use 7,000, for example, or 70,000 as a port number. And I would tie that port number to a common port like 53 for DNS. Okay. So I can send all the DNS traffic to 7,000, and then from that port, it's going to then tie to my common port, which is 53. And for various reasons, they would be able to do this also to reserve bandwidth, etc. Okay. So port forwarding, you can find that on the bottom of page 5, going to page 6. So let's talk about proxy. Because proxy is so important in networking and also security. So you have transparent proxy, which is the next answer for your question. And so transparent proxy is configured as a default gateway, so that way it will pass data to your client system. You can, so basically, they might set up 100 transparent proxy. It acts as a default gateway, kind of like your router. So it's going to be able to send that to different part of the network or other networks. We do this to also increase performance in our network environment. Instead of using one default gateway, we're able to set up proxy. We can also screen with proxy. So for example, I might have 5 proxy that's going to handle the student network side, and I would have 10 network proxy, transparent proxy to be able to handle, you know, the transfer, the pass of data to on the employee side, right? And then you have the non-transparent proxy. This is going to be the application that points to the proxy server. So it basically acts as a way to send that, you know, information to the actual proxy server. You would see that in an enterprise environment, they have many proxy. This is a way that we can integrate network so that way it can give us higher bandwidth. And then you can do content filter, like what I said. You see this in public school quite a bit. There's regulation that students that are 17 years and under are required to be censored from the activity on the network. That means that they cannot watch everything on YouTube. They cannot, you know, so it's going to be censored for the younger viewer content. So with that, we need to be able to block the websites. So you can actually block with content filter by doing proxy. The way that I think about proxy is like traffic police, right? You can say this side go, this side stop, red car can go, white car needs to not go this way, you know, so you can regulate traffic with proxy. You can also implement it with network address translation on how you would use your public IP, and so you can maximize and optimize your network environment that way. You can also use it for authentication and authorization, especially if you're working with remote access. If your company is mostly remote, you can set up proxy to do this. And then you can use it to also serve as a caching mechanism. So that way, people who are visiting your web server, they're not waiting a long time to load the content. So we would be able to cache that so that way the web pages can be reused through the cache data to return the page. Okay. And the favorite thing that cybersecurity students often hear about is going to be reverse proxy. So this allows the user to send the request to the internal web server, but it's passed through this particular proxy to check for the request. So in order to do a man-in-the-middle attack, you often see that they put up a reverse proxy. This reverse proxy would then act as an agent to be able to intervene your request and send it to their system. And that's typically being done. Okay. Okay, so let's take 13 down and move 14 up. So with that, we should answer number 13. What's the primary difference between your transparent and non-transparent proxy server? Transparent proxy server are network devices that are configured as default gateway. So usually they're network appliances, and you can use an actual computer system like a server to be able to pass data. So remember that these are middle system between your network to perhaps other segment of your network. So it would act as your default gateway, kind of like the router. And then your non-transparent proxy would just be applications that point to your proxy server. So software configuration on here, and then be able to send all of that to your transparent proxy. And we talked about 14A, the server that ensures the user authenticated to the network before being allowed to access the internet is your authentication authorization proxy. And typically you would see this being implemented with authentication server or for remote access as well. You still have to authenticate. And then if you want to allow internet user to send requests to the internal server, passing through a proxy, then to verify the request, that will be your reverse proxy. For blocking certain websites based on the content, that will be your content filter proxy. And then if you want to set up something similar to a firewall, and you see the firewall has this mechanism for the rule-based firewall, you would see that it would implement protocol rules. Why protocols? Because protocols is associated with service. Like for example, DNS, right? Or DHCP, or so the protocol, and then also the service is tied to port number. So that would allows it to check for the rules, whether it allows or disallow a certain type of protocols for the service. So internet protocols like HTTP, that type of things too. Any question regarding proxy? So like I mentioned, right, we would use network appliances for this or your systems. Okay, in the next part, it's going to talk about unified communication. This is a big area of the network, especially if you have an enterprise that have call center, but we use a lot of this. When you work in IT security services, you are going to see the predominantly you know, this part of the network is going to be part of your IT service, meaning that you might have to do like use like a tool like TeamViewer to be able to remote into someone's desktop to fix their system, and then be able to communicate with them through video conference or phone, which is now we mostly use voice over IP. So the technology that allows you to communicate close to real time, I don't really believe in true real time. There might be a very tiny bit that's off, but yeah, so when you FaceTime with people, you video conferencing, right? And so we're using the service and the communication application for that. So voice over IP allows you to use phone systems, and each phone has an IP address that you can connect your phone to your switches and be able to use your phone to call. Now you can set up your voice over IP switches to allow certain extension, and this is what you see, right? Extension that's tied to an IP address that would be to that phone and the message box for that phone. So voice over IP. Then you have video. We see this with Zoom and a lot of different type of application. And then your desktop sharing, such as TeamViewer. And then instant messaging, your chat. So instant message is, you know, not always supported in a regular work environment because sometimes they might not allow it. But if you're using Teams or even Zoom, you're able to chat through that as well. Right. So sometimes you have application that is capitalizing on multiple services. So that way you would see real time or close to real time communication. So that is a requirement of the network administration part if you're looking at network services. So if you work in the department that does only network services, we have to manage these systems as well. And the software, the hardware that comes with it. Not just, you know, the servers and the network appliances, but additional client systems and also the application that runs on the client systems. So IT services overall encompasses network services. And usually that's a separate a subdivision of the IT services. That's what you typically see. In a smaller business, you would have like 1 or 2 people that manages everything. But in an environment of an enterprise, you would have a whole division that just do the network part. And so for a facility like this or university, you're going to have audio and video visual people that handles like projection, screens, and all of those related type of unified communication systems. So, you know, video might fall under them and voice over IP might fall under them, but then voice over IP is also going to be under the network services division. Okay, so let's talk about, so I hear a lot of employers telling me that they like asking questions about QoS, especially if they're interviewing apprenticeship or internship students, because they want to know if you understand what kind of things that goes into quality of service. So QoS, you can find this on the notes on page 7. So if you're on a video conference call and if there's a lag in the network environment, you are going to have a delay in the video and the voice. And this is what we saw in the 90s because our network traffic, the rate, the speed, the throughput was not all there. Now, in your work environment, you would see that you need to make sure that the performance meet the user expectation, right? And if it's not, you're going to get a service ticket. So quality of service is a way that we can implement services to prioritize or create, actually improve performance and making sure performance meets the needs of the user. So we can do it through prioritizing network traffic. This is called traffic shaping. We can control how the flow of traffic can increase. So for example, I might have one segment that doesn't have that much priority, then I would allow another network segment to have more bandwidth for priority. If you work for Twitch or streaming companies or YouTube, things like that, a lot of things are priority. That's gonna be your unified communication systems, right? Your streaming servers, your chat servers, your all of those, like even Discord you would see, because you have constant communication. So you're gonna have to prioritize, give or take. There's limited amount of bandwidth that we're gonna have based on the cable that we're using and the system that we're using. So the way that we can control it is we're gonna give or take. You can have more flow in one area. That for Twitch, that will be their streaming part, because that's the money maker, right? And in an e-commerce environment, that's gonna be your web server, your DNS, your users, your databases. That's gonna have priority, because if they cannot find the product that they want to buy, likely that they're not gonna buy, right? So you have to look at traffic shaping is really tying into business operation. You have to look at the processes in businesses to really shape your traffic accordingly. And then your class of service, this is going to be your layer 2. This is what you see with the switch, and you would use your priority quota point. So there are different ways that you can implement quality of service in your network environment. So for 16, we're going to use traffic shaping to prioritize your network traffic. We're almost done. It's a lighter lecture today. Next week, it's going to be a little bit more. Okay. Now I want to talk about the last two before we go to the next question. So differential services, we can use this to achieve traffic shaping. And basically we create rules, and the systems is going to follow the rules to prioritize. So we can say that when the traffic reach a certain percentage, right? This rule can be set, then prioritize this part of the network for the bandwidth, using more bandwidth, where reduce this part of the network. So you can set up rules that way to regulate the traffic, kind of like, you know, how they see if there's like congestion on the road, they might open another lane for, you know, the fire trucks or the emergency vehicle or the priority vehicle to go through. Okay. And then you can also use DHCP, which is a way that we can implement that with your IP header, and that it's going to check this, right? In your network appliance, you basically set this up in your network appliances. Like your multi-layer switch. Okay. So I want to touch on some of these devices. You probably know about voice over IP phone. We talked about that. PBX, if you go to public school, some of them still use this, you know, like when they call you to go to the principal office over the big announcer. Typically that uses a PBX system. This phone system has a server, it has switches to be able to accommodate that, right? So we can broadcast the message to all the receiving audio systems in the room, or we would be able to send messages across the campus. So, you know, PBX is old. If they're still using PBX, they're using like outdated technology, but in the case you run across them, you have to maintain them. The parts for these are very, very expensive now because it's supply and demand. Like nobody, in my opinion, everybody should go into voice over IP, adding switches to that, but you might have school in the remote area that they might have this still, right? Or businesses that might have it. Okay, so before the distributed switch, it talks about how you can set up rules. Rules can be checked with the type of protocol, right? The IP address, similar to the port. So that's basically what you see with the firewall system. Rule-based firewall system is that it checks for those elements before it passes the traffic. So some appliance will be able to allow you to have that kind of control for access. And when we say access control list, basically it's going to check the rules to allow or disallow. Or you can also specify specific system name or IP for the rules. So for virtualization environment, let's say that I want to have multiple virtual systems or servers. If I'm running like Hyper-V, which is Microsoft product, or VMware, you would need to use a distributed switch. Okay. These type of switches are different than your typical regular switch. These switches will be able to pass traffic on to the other switches, or the other systems, which is what we see with virtualization. Virtualization, because of the resource requirement, you would need to implement that with the distributed switch. And then lastly, your software defined network. So we talked about like network management type of environment using the protocol. What you can do is you can use software-oriented systems to be able to set up your network names and IP address so that way you can connect to them virtually. This is really convenient for administration purposes. SDN is like the thing for most networks. So that way you can, so let's say that it's 2 a.m. in the morning and I need to like service I need to configure the switch because something is wrong, right? I would connect to the systems remotely and be able to configure. Now you can use PuTTY to directly terminal into the system. That's an application that we'll use. And I hope to get the appliances here before the semester ends so you can have that physical experience with the actual switcher router. This class, I might be able to accommodate with the existing system. So after next week, I will pull out your switches and routers and then you'll be able to do that. But my Monday class, because there are 50 students in there, I need the district to, if they have resources, so I can get their old switches and routers and I can set that up. But you can use the software to be able to connect to your appliances so that way you can configure, update, those things. And so that way you don't have to be physically there at the data center, because sometimes, you get a call at 2 a.m. in the morning and you have to fix something real quick. Unless, you have an attack and it shuts it down, you have to physically drive there and then you have to go there. So, but usually they have technician there that's be able to accommodate that until you get there. So, yeah, so SDN is a way that we can use the software to be able to connect using names and IP addresses. We just need to configure that. And then we can implement like Python scripting for automation. I was telling my programming class yesterday, I was like, when I teach Python for security and networking, you can write like 7 lines and you can have the configuration in that and you can send it to all the servers that's receiving that configuration. Like, let's say that I need to run a patch. I can loop that for all my systems and be able to do it. Okay. All right. So what we'll do is we will wrap up the lecture. The last answer is for SDN, as you can see there. I will stop the recording. We'll take attendance. I'll give you a few minute break and then we'll do the lab.